Welcome. Today's lecture preliminary hazard analysis. The content a preliminary hazard analysis. Actually, we will discuss only PHA, preliminary hazard analysis. So, under this, these are the few things which are part of PHA. One is overview, then what is the methodology, the worksheets you require to represent the PHA, document PHA, and then risk index, hazard control hierarchy. Some examples will be given to you. Obviously, the same book, hazard analysis techniques for system safety. Please keep in mind, those who are first going through PHA without PHL, preliminary hazard list, my previous lecture, preliminary hazard list, you will face problem. So, I request all of you first go through PHL, if not gone through, and then understand PHA. This PHL and PHA, they are basically very much related thing. PHL is the input to PHA. So, let us see that. You see, I told you, if you recall that in PHL also this kind of process diagram I have given, and in PHA also it is given, and in PHL we have given that design knowledge, then hazard knowledge, and then lessons learned. But in PHA, design knowledge, hazard knowledge, PHL is the input, preliminary hazard list, and this is top level mishaps, top level mishaps. Okay. So, if we consider the S missile system, the example what I have given earlier, there one of the top level mishap is missile structure that crash. So, similarly, that is during launch, then flight. Similarly, the fire in the ground operation, missile structure that fire. So, in the same manner, if we go back, look into the example of pressure tank, the top level mishap will be pressure tank rupture. Okay. So, these are basically top level mishaps. So, top level mishaps are inputs to PHA. What are the outputs? Hazards that you have already also seen in PHL, then accident you have seen in PHL also, causal sources that also you have seen there, that safety critical functions and top level mishaps, that is what is basically input here, output here, but we have not discussed the details. Then mitigation methods and some that safety reviews. So, all those things are the output. And how do you do this PHA process? List and evaluate each PHL TLM for hazards. You have PHL 1, PHL 2 like this. In SMSL system there are 50 PHL, preliminary hazards. So, every PHL there will be some top events, top level mishaps. So, you have to list all them. Then you find out if there is any new hazards. Then evaluate hazards through thoroughly as design details allows and document the process. So, that means it is intertwined with the PHL. The PHL process and PHA process, they are basically overlapped to one, but PHL will help you in doing PHA in a better manner. So, sometimes what happen, we do not do PHL, we will do PHA starting from the first step of PHL and end of PHA. Okay. So, you just see the steps. Define systems, you have seen in PHL, plan similar to PHA, establish safety criteria, it was not there. Identify acceptable safety design criteria, safety perceived principle, safety guideline and safety critical factors. So, that you have to establish. Then you acquire data, and I have told you what is this acquire data. For okay, obviously you are saying that safety design criteria like safety factors. Okay. So, safety perception, safety principles. So, different there can be many principles, many companies followed 10 to 15 principles. Okay. Inspection is one principle, HERA is another principle, like many things. There are safety guidelines and obviously safety critical factors related to humanware, software, hardware and the interface, all those things will take place here. Acquire data, fine, that you understand, and conduct PHA. See, construct list of equipment function, it is like PHL. Prepare worksheet for each identified equipment item like PHL. Compare hardware with hazard checklist TLM PHL. Compare system operational function with work hazard checklist TLM. Show operational function, hardware, energy sources, then software function, all you compare. These already you have seen in PHL. But okay, suppose you have not gone through PHL, you want to do jointly. So, then all those steps you have to follow. And I request all of you to first see my PHL lecture, preliminary hazard list lecture, then follow this one. Expand the list of safety critical factors or TLM and utilize in the analysis. In PHL, you found out the safety critical factors and top level mishaps, but here you expand the list. Be cognizant of functional relationship, timing, concurrent function. I have already told you that dependency between components, between one layer to another layer. Now, utilize hazard and mishap lessons learned from other systems. Then few things which are basically new, what is not there in PHL, evaluate risk. I told you risk is probability times consequence. This principle we will be using here for every PHL, every hazard. Then recommend corrective actions. So, what you want? You want to do some things so that the risk will be minimized. So, there, that is why I have kept one concept in the lecture, that is hazard control hierarchy. Hazard control hierarchy. So, you have to, once you evaluate risk and if it is unacceptable, suppose okay, whatever may be the level of risk, you want to reduce it, then you require to give some actions. So, take some actions to give some suggestions. So, some control measures. So, using hazard control hierarchy, you can get some control measures. Then monitor corrective actions. Review test results and ensure that the safety recommendation and SSR are effective in mitigating hazards as anticipated. This is basically, once you improve, it must be monitored and maintained. Then track hazards, whether the hazards are still occurring or not. Transfer newly identified hazard into the hits, update the hazard top and okay. So, what I mean to say that if you have any new identified hazards, you just feed into the list. Then document the entire PHA process and PHA worksheets in the PHA report, include conclusion and recommendations. So, these are guidelines. So, how to do PHA. So, what I told, obviously these are descriptive. So, once you read further, you will know that what are the things are there, but please follow these steps, that is what is the issue here. Then when you try to document, the documentation is having how many components? 14 components. First is system, subsystem, function. लिखना पड़ेगा. What is the system? What subsystem? Then who is the analyst? Who is date? these are the minimum basics. Then number, it will come from 1, 2, 3, suppose system number, then suppose hardware number item 1. What are the different hazards? Hazard 1. What are the causes of that hazard 1? Then what are the effects of hazard 1? What mode, means when it has occurred, maybe is it during the operation or during the maintenance, or maybe during, in case of S missile case, during flight, during ground operation, where it is, or in case of the material handling system in a steel plant, where it has occurred, during when the torpedo on the track going to ladle, or basically it is the Utic crane transferring the ladle. So, where it is, so that sense. IMRI stands for initial mishap risk index. So, that means you have to know the hazard, what is the probability of occurring and what is its consequence, then that multiplication of this P and C will give you initial hazard mishap risk index. Then what happened here, you want to reduce this risk, then either you reduce the probability of occurring or consequence of that event, or both. Then that recommendation may be related to prevention, related to mitigation. When you are basically giving recommendation to reduce the probability that the hazard will not occur, or probability of reducing hazard occurrences, that is the prevention. When you are thinking, okay, hazard occur, but its consequence can be mitigated, then it is basically mitigation. So, it can be both. So, then you find out the preventive measures, mitigative measures, then you put here, and then what will happen, if both preventive and mitigative measures found out, then this both P and C value here it will be reduced. I will show you with one example how it is done, and then you have to give the comment. Comment means whether that is implemented, recommendation implemented or not, or what is the feasibility, cost component, all that. Those things you can write, and under status you write the implementation status. If it is implemented, closed; if it is not implemented, open. Under comment you can write many things, whatever you find relevant. So, in PHL we have given a very small documentation items, I think 5, 6, but in PHA 14 items to per hazard you have to write down. 4 items are common, 5 to 14, 10 hazard specific information you have to give. So, now the issue is that how do I find out the initial mishap risk index or risk index? There are many ways to find out risk index, but here a subjective or qualitative way of risk index calculation is there. Severity is the part of consequence, probability P, probability, as we have told that risk equal to P into C. So, now finally, this can be, once you know the probability in the quantitative term and consequence or severity in the quantitative term, then risk will also be in the quantitative term. So, that is quantified risk, which is basically objective in nature, then it is quantitative risk assessment. The scheme adopted in PHA is usually qualitative risk assessment, not quantitative risk assessment, because quantitative risk assessment requires data of probability and consequence values, and that too for every top level accidents or every hazard you have to find out, then it will be a huge task. And as PHA is done usually at the system level, but encompassing all the component system subsystem, to get an idea first that what is the hazard level, what are the different kinds of hazards available in the system, so that a exhaustive list of hazard can be found out. So, then and their index risk value may be given in a qualitative term. By qualitative term, what do we mean is given here. Severity can have 4 different categories: catastrophic, critical, marginal, negligible. For example, we may say if there is a fatality, suppose one or more fatality, that may be catastrophic. Or sometimes people say no, it is catastrophic if even not one, more than one fatality is there, but okay, fatality is a big issue. Critical, we can say okay, from human safety point of view, critical may be permanent loss of body parts, okay, amputation, maybe your eye or something like this. Marginal, which may not be leading to any kind of the disability, but it making maybe absent from work. Negligible means maybe first aid kind of thing, first aid. So, but you may say that no, my system is such that it is not the human safety only, it is a loss control point of view, that human, property, environment all will be important. Then what you have to do, you may find out the equivalent that law quantification or loss in terms of money. Okay. So, maybe human loss, then your property loss, environment loss, all loss you compute and then find out your categorization of catastrophic, critical, marginal, like this. For example, if a accident can cause suppose rupees 1 lakh or more, 1 lakh means basically or if we say 1 million Indian rupees, then it may say it is catastrophic, but negligible if it is the ultimate loss is 1000 rupees, Indian rupees. So, that conversion is also possible. But if you can make in terms of money, then it is quantitative. So, what I mean to say, qualitative mean you must have an idea that your loss value beyond certain level is catastrophic, within certain level is critical, within certain level is marginal, within certain is negligible. Usually from severity in terms of human safety is considered. So, that means this is a 4-point scale for severity. Similarly, probability it can be quantitative, can be qualitative. Qualitative mean frequent. Suppose the work has been done 100 times, 10 times it has that incident is occurring. So, that is frequent. Probable, maybe if I say that okay 4 times or 4 to 5 times probable out of 100. Occasional, maybe 2 to 3, and remote maybe 1 to 2, improbable less than 1. So, something like this, but at the qualitatively you please understand that there is no, in qualitative risk assessment for the severity scale as well as probability scale, there is no reference point. Okay. It is basically used for ranking purpose. So, for my own system, for considering all hazards, if I stick to this, then when I compare first risk with the second hazard risk, then what will happen? It will the difference ultimately is significant, not the individual value, difference will be significant, that for improving the for ranking. But from improvement point of view, if catastrophic severity is there, it is to be reduced definitely, otherwise do not do this work. But that means if your this one cannot be reduced, then it should be E, improbable. The principle is like this: if I say this is my probability and this is my severity, then if I say this is high and this is low, then this is high and this is low, then high probability, high severity means catastrophic and frequent, impossible. This quadrant big 0, it is impossible. If your system is having this, that means this is not a working, people cannot work here. Then here probability is low, severity is high, it may be there. So, that means what happen, probability low, severity high. So, your severity must be reduced, your prevention measure will be severity oriented here. Now, probability severity both low, this is the most desirable one, and you find out that in general day to day all activities will fall under this, and here probability high and severity low, that may be there. Here what happened, you reduce the probability. So, action here I think it is inoperable system, action here reduce the catastrophic nature or the severity, action here reduce the probability, action here I think it will, the risk level here fall under acceptable zone. So, that means what happened, for every hazard, suppose PHL 1, you know what is the hazard. Now, you have to see that what is the probability that it will happen. So, you may say it is remote, then probability value is D. If it happen, what is the consequence, you say it is catastrophic, then it is 1D. This is my initial risk index. In this manner, in PHA risk index is written. For the second hazard, suppose PHL 2, so you may say, for example, here PHL 1, the missile body that crash, the catastrophic, but it may be remote possibility. Suppose the second one, that the when the I can say the tank rupture, that also will be catastrophic, but its probability is again remote or improbable. Maybe the when the material handling the torpedo is going, so if there is a fracture rupture in the torpedo, what will happen? It will again, it may again lead to catastrophic, and but it may be improbable. Okay. Suppose you just think of that somebody is carrying something, so there is a possibility of slip and fall, it may be occasional. It may be occasional. So, slip, trip and fall, that may be occasional, but if you go by the consequence, it may be marginal. So, then the IMRI is 3 C. Here you may be interested to reduce this one. Okay. In this manner, initial risk index is computed. Once you have the risk index, then what is the next? Next is how to reduce the risk. So, here is the concept called hazard control hierarchy. Hazard control hierarchy. So, far I know Junior Haddon has given this, that means that elimination, substitution, engineering control, then administrative control, personnel control, these are the 5 stages. Elimination means eliminate the hazard during design, that is the concept of PTT. That during design, before designing, at the design room, if you understand, if you have done PHA, then all the hazards are known, consider one hazard and then see that whether this hazard can be removed at the design stage. If it is, remove it. Now, that is what we say that elimination. For example, working at height, if the work can be done at the ground floor, so get it done there. Even though you know working at height, if you do at the height, it will be better from the efficiency point of view, but from safety point of view, it is not. So, elimination is there. If you cannot eliminate, substitute a less hazardous material or form during design. Please keep in mind during design. So, okay, it is not elimination not possible. Working at height cannot be eliminated totally. Some cases it will be there, but please understand that suppose the maintenance person, he required to carry certain material, so can it be eliminated? So, the load part can be eliminated. So, that means that little less. Okay. So, that is substitution. For example, the pressure tank system, you are suppose the instead of gas you are using toxic gas. So, the toxic gas is the hazard. Now, if the for the operation point of view for the pneumatic control machines what the gas will be used, who will be used, where the gas will be used, here if it requires ordinary gas, then what happen? Instead of toxic gas you are using ordinary gas, but you are using toxic gas because toxic gas may be available which is produced by your system. For example, in steel plant what happen? Coke oven gas, LD gas, blast furnace gas, they are all toxic gases, particularly coke oven gases. So, these are plenty of such gases available. So, in another place where you want to suppose pressurize something, use those gas, but please keep in mind if instead of that coke gas, coke oven gas, some other less toxic gas or no toxic gas available, it is better to use. This is the case of substitution. Then engineering control, design in engineering control. Engineering control, basically what do you mean by that? You are not able to eliminate the hazard or substitute the hazard. You have to work with the hazard. Now, from energy control point of view, work with the hazard means suppose the pressure tank, the pressure gas you will be using. So, that means you must have some control so that the overpressure condition will not occur. Okay. So, overpressure condition will not occur provided some mechanisms are put, let it be you have seen already pressure gauge is there, alarm is there, so relief valve is there. They are basically for what purpose? To avoid the overpressure condition. So, these are all engineering controls. Now, elimination, substitution and engineering control later on we will be discussing in detail when we discuss that safety function deployment. I will discuss in detail how it will be done, but for the time you understand these three are basically considered the PTD, prevention through design. Whatever PTD you adopt, all administrative control is also a must. So, for every hazard what you identified, for some may be PTD related solution, somewhere administrative solution is also related. So, those you will find out. So, well designed work methods and organization is administrative control. SOP must be available, SOP must be adequate, SOP must be followed, all those things how do you know? It is administrative control only can do it. Then last but not the least, PPE is also important because occurrence of hazard is a probabilistic event. Whatever you do, there is a chance. So, PPE must be used. It is basically least effective, but it is a must. So, reliability of control, if you see, the elimination is the best method, PPE is the worst method. But this lower reliability to higher reliability. So, your order of execution should be rank 1, rank 2, rank 3, rank 4, rank 5. Your execution order will be like this, first this. That is the reliability pattern. Okay. I hope that this makes sense. Now, let us see that the documentation part with an example. What is our example? ACE missile system, then PHA 1, you have already seen that missile structure fails resulting in unstable mission flight and missile crash, causes manufacturing defect, design error, effect unstable flight resulting in crash during death like this. This is basically this hazard and effects and initiating mechanism. This is the total hazard list. This is the first hazard and this is the hazard triangle basically. Then where which mode? It is in the flight mode. What is the initial missile risk index? Catastrophic in nature, remote occurrence. So, what is the recommended action? Use 5 times safety factor on structural design. Then what will happen? D will be converted to E. So, D is probability, E is also probability, improbable it is remote. So, that means prevention, it is a prevention comment basically this action if you take then what will happen? Probability final risk mishap risk index FMRI final mishap risk index. Open means it is not yet done. Similarly, other one. Okay. So, what we have learned then? We have learned then that PHL and PHA one actually PHL and PHL are overlapped. PHL is the input to PHA. So, when you do PHA, you must have PHL, the list must be available. So, and the process is given to you. Second thing is that in the hazard list you will find out so many hazards PHL 1, 2. So, like this there will be PHL n, so many hazards are there. So, the format is given. In that format you have to write down the causes, the hazard, the causes, the effects, initial risk index, then recommended action, then final risk index and so forth. Okay. So, I have given you only that SMSL example here, but the hot metal transfer case also similar things we have prepared. Your pressure tank system you can prepare, you have your own system, there also you can prepare. So, in between some cases will be discussed, there also you will see further development. So, in nutshell PHA which includes PHL also is a very effective hazard identification technique which can be used at the design stage. Okay. It is applicable to the entire system and the primary purpose is here to find out all purpose whatever the different level of hazards available there. Okay. So, maybe PHL can give you a very big list of hazards. Okay. So, then what happened through risk analysis and other measures you may finally come down to a few risk or hazards which require maybe further analysis. So, this is known as, this can be understood in Six Sigma terminology, this is funneling effect. So, we have large number of hazards and then we want to find out the very few significant one. So, that means there may be vital few hazards and trivial many. So, what happened, but PHL ultimately work at this level when we want to find out more, because it's basically at the system level, plant level, department level it can be done. But whatever you do, you please keep in mind that a team is required, Your design knowledge, system knowledge, the design knowledge, hazard knowledge and lessons learned. These are very, very important. Your design knowledge will be compared with hazard knowledge, design will be compared with lesson learned, then the design gap will be identified and new hazards will be identified also. Second is that the system breakdown structure, system breakdown, which I have discussed in PHL lecture. So, that means system there will be hardware, there will be humanware, there will be software and system can be broken down to subsystem, subsystem to component level. So, you can at the component level, that means the hardware item, every item you have to find out, then the energy sources and hazardous processes and events you have to understand and accordingly you have to find out that what kind of hazard can be there. In the conceptual lectures I have talked about hazard triangle. It is nothing but PHL will give you many hazard triangle and PHA will give you how many hazard triangle are, what is the amount risk and what kind of actions can be taken so that that risk can be minimized. We have discussed in the qualitative way the risk, qualitative risk, that means P in 4 maybe 5 point and C in 4 points. So, you have in total, that means you have in total that A, B, C, D and E, then 1, 2, 3, 4. So, how many risk value? So, that means in your case there will be 20 risk values. So, this one is 1 A and this one is 1 E, similarly this one is 4 D. So, the higher this is the higher the consequence and the higher the probability, that is the worst thing. So, that means in the first few quadrant like this, all those things, these are very serious one. Maybe here also this should not be there. We must avoid this. Similarly, maybe you will find out that 2 this and this may be not, maybe only 4, okay, this fourth case, this may be acceptable case. So, if your original risk is falling here, that 1 E, so you please see that it may be acceptable, but if it is 1 D, it may not be acceptable. In that case, thus D must be converted to E, and your recommended actions will be how to convert this probability of occurrence, reduce this from D to E. That there the hazard control hierarchy will play a role. But please keep in mind here hazard control, all those things we are talking at the very abstraction level. The nitty-gritty detail, if I say elimination of hazard or substitution of hazard or engineering control, we are giving you here in broad based engineering control, not the specific engineering control. The specificity comes when you actually design design and you have the design knowledge, you know the everything. Then automatically, because of the team's knowledge, this concept, once you apply the specific items, you will find out from hazard control point of view. So, wonderful technique, very easy and easy to understand, but very difficult to do in reality, because domain knowledge, hazard knowledge, design knowledge, lessons, all those things are prerequisite for doing PHA. Okay. I hope that you have understood it, and you will definitely be able to develop case, because what will happen when we give you the assignment, we will be looking for such a case specific assignment from your side also. Okay. Thank you very much.